Hi, my name is Michael Metzing, and today we're going to be talking about the free agency market decision support system. So, in professional sports, players receive contracts for monetary values and lengths of time based on the amount of time and money a team is willing to put into a certain athlete. It is pretty obvious that the stars of the sport will receive the most money, and nowhere is this more true than in the NBA. Out of soccer, baseball, football, hockey, and basketball, the NBA has the smallest roster size. This also means that every roster spot is more valuable. When a player's contract expires, that player is called a free agent. Free agents are available for any team to make an offer to. Obtaining a player in free agency comes down to a variety of factors. These factors include the value of the player, the likely salary of that player, and things of that nature. The value of a player in this project has been calculated using player efficiency rating. Player efficiency rating takes the major stats of a player and assigns a value to that player. This includes field goals, assists, rebounds, defensive statistics, and other statistics alike. This is the calculation for the problem. And the likely salary in this problem is using the previous salary from the year before. MyDSS uses a LP model through the use of solver in order to calculate the best player values as additions to the user's current roster. After going through the welcome page, you have the option of entering your own data or letting the program input data for you as a demonstration, just to see how the program works. So now that we're at the welcome screen, let's check how running the demo actually works here. So I click Run Demo, and what shows up is the team roster page. The team roster here shows some of the players from the current roster of the NBA's Philadelphia 76ers. The 76ers here have 10 players on their roster. This roster here is excluding any players that only have 1 year contracts, as those players are able to be inputted as players who are going to be free agents next year. So using the find best fit player, it will go through and make additions to the roster. You can see the additions here highlighted in red. These additions give the user the highest player efficiency rating while still staying within the bounds of the salary cap. And now to look at some of the functions that we use throughout our program. Um, Here's the demo data. So what it does is it takes the demo data from a sheet and it just copies and pastes it into the team sheet. This is something that was used in a couple of our case studies, and I thought that was cool. And it just made it easier to show an example for this problem, so that was interesting to learn. Now going into initialization, that's how I initialized some of the variables that we used in our solver, which you'll see in a second. Um, some of the more notable pieces are the max and min salary cap for a team. That gives you the values that the team is allowed to meet, and within our problem constraints, it was said that we were only allowed to go to at the lower end of our salary, 0.9 of 90% of our max salary, and this set of calculations here was used to really go through for loops that you'll see in the future, and in order to show the data in a more accurate way that was more usable for the user. And now looking at run solver, we can go through and we see that it calls the initialization function, which is above here. And these are a bunch of the different variables that come into play with the linear programming model that I showed before. And this is most of the calculations of them. Using offset was a huge help as well for this project. And So going through Solver, I needed to make sure that whether the player was selected or not was a binary number, and those were um, my variables. Those were the numbers I could change. And then making sure that the total number of players or the total number of players at each position was less than or equal to 4, so you don't have a full team of one position. And then this set of constraints is for the salary cap, and this one is for the number of possible additions that you can have to your team because the team roster cannot exceed 15 players. Right here is where we see the additions come in to the actual team data sheet, because these up here, the solver is just calculations. This is where the user gets to see where his values come from, what values they are, and what was actually changed in the sheet. Um, so what did I learn from this project? The first part was just making the model look nice. It was more pleasant for me to look at, and I know it's going to be more pleasant for a user to look at. Just the idea that it looks professional, it looks like something that you would actually want to use. I also learned that ensuring that I have an error-free project makes the system more pleasant to work with. Going through some of these case studies that we've had, we've seen some slight errors from going back and forth into things, and just learning how to fix those small errors will really save you time and some frustration in the long run from having to close out and go back into your workbook. So just making sure you have an error-free project at each phase. And then the last part is just double checking variables. And what I mean by that is I accidentally named some variables the same thing multiple times throughout this project just because there's so many pages where it would make sense to name it the same thing. But obviously you can't do that. So just looking at the variables and making sure to check to see if a name has already been used will cause less headaches in the future.